All right, let's get started on section 6.6 about inequalities in two triangles. Our objectives: mathematicians will be able to compare measures in triangles. Mathematicians will be able to solve real-life problems using the Hinge theorem. Our essential question: if two sides of one triangle are congruent to two sides of another triangle, what can you say about the third sides of the triangles? All right, let's start by thinking about a visual. When we compare measures in triangles, think of a hinge on a gate, as seen in this image here, a real-life hinge. So imagine a gate between fence posts A and B that has hinges at A and swings open at B. So as the gate swings open, you can think of triangle ABC with side AC formed by the gate itself and side AB representing the distance between the fence posts. And then side BC represents the opening between post B and the outer edge of the gate. And notice that as the gate opens wider, as we can see in the middle picture, both the measure of angle A and the distance BC increase. And you can see by the third image, when the gate is completely open, the angle A is larger than in the middle picture and even larger than the first image, and so is the length of BC. This suggests the Hinge theorem. So let's get familiar with the Hinge theorem. If two sides of a triangle are congruent to two sides of another triangle, and its included angle of the first triangle is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. So if we're looking at our two images here, triangle VWX compared to triangle RTS, if side XV is congruent to side TR, and we can see that by the congruent marks, and WV is congruent to SR, and we can see that by the double marks, and measure of angle R is greater than the measure of angle V, then length of TS is greater than the length of XW. So in other words, when you have two triangles that have congruent sides, the smaller angle, included angle, so that's between the two sides that are marked congruent, the smaller angle will be across from shorter side compared to larger angle across from the longer side. So we're saying that this side is going to be shorter than this side when all these parts correspond in this relationship. So let's look at the converse. The converse states if two sides of a triangle are congruent to two sides of another triangle, and the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first triangle is larger than the included angle of the second triangle. So similar relationship, except we're switching. Now we're looking at sides. But we do still have the corresponding parts that are congruent between the two triangles. So in other words, if you have a shorter side compared to a longer side of two triangles that have congruent parts, then the shorter side will be across from the smaller angle and the longer side will be across from the larger angle. All right, let's take a look at the converse of the Hinge theorem in action. Apply it to this problem. Given that segment ST is congruent to segment PR, how does the measure of angle PST compare to the measure of angle SPR? Well, because the two triangles are sharing side PS, we can mark PS as congruent to itself by the reflexive property. And since the included angles of PST is across from the longer side, and angle RPS is across from the shorter side, we can conclude that angle RPS is less than angle PST, or vice versa. Angle PST is greater than angle RPS. So by the converse of the Hinge theorem, measure of angle PST is greater than the measure of angle SPR. All right, let's take a look at example using the Hinge theorem. Given that JK is congruent to LK, how does JM compare to LM? Once again, we have a triangle sharing the same side, so we can mark KM congruent to itself. So we now have corresponding two sides congruent between the two triangles. You're given that JK is congruent to LK, and you know that KM is congruent to KM by the reflexive property, as I just mentioned. So because 64 degrees is greater than 61 degrees, we can conclude that the measure of angle JKM is greater than the measure of angle LKM. We have our larger angle here, smaller angle here. So we can conclude that the sides of triangle JKM are congruent to the two sides of triangle LKM, and the included angle is in triangle JKM is larger. By the Hinge theorem, side JM is greater than the length of side LM. Alright, pause the video here and try these two problems, numbers 1 and 2, on your own using the diagram here to the right. Alright, check your answers. Did you get for number 1, side RQ is the longer side length? And for number 2, did you get that the larger angle is SPQ? If so, good job. If not, please bring clarifying questions and we can clarify in class. Alright, let's take a look at a real life problem. Two groups of bikers leave the same camp heading in opposite directions. Each group travels 2 miles, then changes direction and travels 1.2 miles. Group A starts due east and then turns 45 degrees towards north. Group B starts due west and then turns 30 degrees towards south. Which group is farther from camp? Explain your reasoning. Let's start by understanding the problem. You know the distances and directions that the groups of bikers travel. You need to determine which group is farther from camp. You can interpret a turn of 45 degrees towards north as shown here. So if we went due east and then we turned at a 45-degree direction towards north. So next, let's make a plan by drawing a diagram that represents the situation and mark the given measures, the distances that the groups bike, and the distances back to camp form two triangles. The triangles have two congruent side lengths of 2 miles, as seen here. The triangles have two congruent side lengths of 2 miles and 1.2 miles, as seen here. Include the third side of each triangle in the diagram, so as we see here. And then labeling all the parts. So we know that we traveled due north 45 degrees, one biker, and the other one turned due south 30 degrees. So this angle here on the exterior is 30 degrees, and the exterior here is 45 degrees. And then we have our two congruent sides. We don't know the third length. That's what we're trying to figure out. Because the exterior angle for the biker that went south was 30 degrees, we could subtract it from 180 to get the interior angle of the triangle, which is 150. And similarly, over on the biker who went north, the exterior angle was 45 degrees, so we could subtract from 180 to get the interior angle of 135. So our included angles are 150 degrees and 135 degrees. Because 150 degrees is greater than the 135 degrees, the distance group B from camp is greater, so this distance is greater than the distance group A is from camp, according to our Hinge theorem. So in answer to the question, group B is farther from camp. So let's just take a quick look back. Because the included angle for group A is 15 degrees less than the included angle for group B, you can reason that group A would be closer to camp than group B. So group B is farther from camp. And that's all for the hinge theorem. The end.